Algebraic inequalities, graphing solutions. All right, so let's look at some examples right away and let's try to make sense of how we graph on a number line for the solution to an algebraic inequality. Let's start with the one that we have here on the left. We have n greater than, that's right, you have to know which symbol means what. The one that looks like the L, which I'll highlight it for you in green over here, that one is the less than symbol. But the one I have highlighted over here in yellow, that does not look like an L, that is the greater than symbol. So here in yellow, n is greater than 16. All right, so the first thing we do is we label the hash marks of our number line. We traditionally put the 16 in the middle. Since n is greater than 16, what could n be? It could be things like 17 or 18 or 19. Well, all of those numbers that are greater than 16 are to the right of the 16. So that's why shading to the right makes sense anytime your variable is greater than the number. But what are we going to put at the 16? Well, it's not allowed to equal the 16. This does not have the equal to bar. So what we do whenever the inequality symbol does not have an equal to bar is we will start with what I call an open circle. This open circle means that we're starting at 16, but we can't actually equal the 16 unless we had the equal to bar on the greater than symbol, which on this problem we do not. So that's why we're keeping it an open circle at that starting point. Now, the example I have over here on the right, we have n. This time it is less than, as I'm highlighting for you in green, less than the 16. So where would I shade? Well, if it's less than 16, it could be things like 15 or 14, numbers that happen to be to the left. That's why we're shading to the left of the 16. Once again, we're going to have to start with an open circle because the n is not allowed to equal the 16 without having an equal to bar on the inequality symbol. Speaking of equal to bars, let's look at two more examples. If I have n being greater than or equal to the 16, then not only could it be 17, 18, and so on, numbers that are greater than 16, but this time it actually could equal the starting number. So whenever it has the equal to bar on the inequality symbol, you're going to start with a filled in dot. Some people call that a closed dot, instead of the open circle that I was mentioning earlier. Now, we're still going to shade to the right, because if it's greater than 16, then we could be numbers like 17, 18. Those numbers are to the right, so that's how the graph would work for n greater than or equal to 16. What if n is less than or equal to the 16? Well, then it could be things like 15, but it could equal the 16 because it has the equal to bar. So again, we're going to put a filled in dot at the starting point anytime the symbol has an equal to bar, this line underneath. That's when you're going to put the dot. And then we are going to shade to the left because this did say n was less than or equal to the 16. That's going to be numbers like 15, 14, and they happen to be to the left. So you're probably noticing that if the inequality symbol is greater than, you're shading to the right. If it's less than, then you're shading to the left. However, I have to warn you, there is one exception. If you get an inequality that is very sneaky and has the variable on the right, well then that changes everything. You probably noticed the examples I gave you here had the variable on the left. That's the way we want it, because in English we read left to right. That's the way we normally read. So what do you do with the variables on the right? It's simple. You just flip everything around. But when you flip everything around, the inequality symbol has to flip as well. And that's why if it's 19 greater than x, you're going to rewrite it as x is less than 19. Notice we're shading to the left. But think about this. If you wouldn't have flipped everything around, would you have known to shade to the left? Probably not. You would have seen the greater than symbol and you would have thought shade to the right. So it's very important. If you see the variable on the right-hand side, you need to do one little step of writing on your paper before you actually graph. Flip everything around so that the variable is written first on the left-hand side. That's where we want it to always be before we graph. So on this example, if it's greater than or equal to negative 63, then we're going to shade to the right because that's where the greater numbers always exist. Why did I not flip everything around on the first 4 examples I gave you? Because the variable was already written on the left where we want it to be. Only flip things around if the variable's on the right. That's when you flip it around so that way you graph in the correct way.